Welcome back on behalf of LTC and APT participant. Warm welcome to the Naveen Naga. He is the young and dynamic engineer in our organization and currently working in the Bangalore city of India. This is the basically electronic city of India. And this young officer, I'm very thankful to him. He is ready for today presentation, and same time our colleague, our another dynamic technical supporter of this course, Mr. Neeraj Gupta sir. You are also welcome for this session.
Thank you.
Now this session is hand over to the Naveen Naga and Neeraj sir for proceed. Yes. Neeraj sir, before starting, you are saying anything, to please proceed.
Thanks to all participants to join such course organized by APT Center in association with Asia Pacific Telecommunity. In this entire week, we more emphasize on blockchain platform, and the session initiated by Mr. M. Naveen Naga from Bangalore, and presently he is working in our mobile section, MSc. Now, session handover to Mr. M. Naveen Naga to please proceed the understanding of blockchain platform and consensus algorithm. Thank you.
Thank you, sir. Sir, can I take over the session now?
Yeah.
Okay.
We already make you a co-host.
Okay. Yes, sir.
You have
Thank
full
you.
privilege.
Okay. So, hello all. Good morning to you. I'm Naveen, as Krishna sir and Neeraj sir has introduced me, and thank you for giving this opportunity, sir. So, let us start today's session. The heading says, or the topic says, understanding blockchain platforms and consensus algorithms. Everybody here might have some basic idea, like what is blockchain, cryptocurrencies. We might have heard this term, cryptocurrencies. So we are going to dig deeper into this concept today. What is a blockchain? How it works? Why it is required? Where it will find its applications? How we can use this blockchain to enhance our daily life activities, and how it will help our nations to develop. Okay. So before starting the actual topic, let me give you some suggestions kind of thing. If you get any doubt in between, please ensure that you type your question in your chat whenever you get doubt, or otherwise we can follow, like, you note it down. You can ask your queries and all those things at the end of the session. So we'll follow this approach then. Note down your queries, type it at the end of the session so that we can discuss and answer those of your queries to get a better understanding of this topic. So with this thing, I'm going to start this session. First of all, this blockchain presentation contains some different topics or different scenarios where we are going to discuss how it started, the history, and how it has been developed, and where all fields it is going to find its application, and all those things we are going to discuss one by one. So let me tell you briefly the contents of this presentation. First is the history of blockchain, how the blockchain has come into existence, whether the blockchain has come into existence all at once, or it started with a small concept and slowly evolved and finally reached this particular stage where we are looking at it as a technology which will disrupt so many systems. Next, introduction. After discussing the history of blockchain, we are going to get introduced to this topic, introduction. Next, what is the need for blockchain? Without knowing the need for blockchain, even though if I explain how it works, it will make no sense. So first I'll tell you why blockchain is needed. Okay. Next, how it works, how the blockchain works. Then the consensus mechanisms. The consensus mechanisms form the core of this blockchain technology, which we are going to discuss further in this presentation. Next, types of blockchain. There are different types of blockchain. So we are going to discuss what are the different types of blockchain and where they are used. Next, the blockchain platforms. There are different blockchain platforms. Besides types of blockchain, there are different types of blockchain platforms, which we are going to discuss in this presentation. Next, key characteristics. Next, finally, we'll sum up this presentation with the applications of blockchain. I hope everyone are following what I'm saying. I hope so. Okay. So, first of all, an US billionaire businessman, Abigail Pierpont Johnson, she told that blockchain technology isn't just an efficient way to settle securities. It will fundamentally change the market structures and maybe even the architecture of the internet itself. By these statements, she means that blockchain is not just a simple technology, which is a better technique to what do you say, to settle the securities or to make transactions. She opens that it will fundamentally change, or she's saying that it will disrupt few of the markets and it will completely change the way we look at the few of the mechanisms. Okay. So with her statement, we can understand how important this blockchain technology is and what such a big role it is going to play in our daily life in future. So first of all, as I said, let's see the history of blockchain. What is the history of blockchain? The history of blockchain dates back to 1991. Yes, though it sounds to be very older technology, 1991 was the start of this technology. As I said, blockchain is not a technology which has evolved all of a sudden at once. It started with a small thing, small requirement, then it slowly evolved over a period of time to finally come to this particular stage. Okay. Now, initially, this blockchain technology was described in 1991 by a group of researchers. In that group of researchers, the prominent one were Stuart Haber and Scott Starnetter. So these two people, initially they thought to find a solution for timestamping digital documents. Like generally, we will write a ledger that is like offline ledger in pages. We'll note down the date of some activity and then the second activity on particular date on which it has been carried out. This is called a ledger. And if you do the same thing online, this is called as digital ledger. Okay. So they wanted to timestamp these digital ledgers. So they wanted to put a kind of time at which this particular digital document has been created, or particular this digital ledger has been created, like that. So in the process of finding a solution for timestamping these digital documents, so that they could not be backdated or tampered. Why this requirement has come? Because if you timestamp a digital document, that particular date cannot be changed. And because of that, we can say that the digital document can never be tampered, which is very much important for the security and trustworthiness of that particular document. Okay. Next. So to overcome this difficulty, they developed a system using a concept of cryptographically secured chain of blocks to store these documents. First of all, they were successful in creating timestamped documents, and they have combined all such transactions into a block. Okay, but the improvements came further. In 1992, there is a concept called as Merkle trees. They were incorporated into this design. So this Merkle trees is a old technology actually. This has been proposed by Ralph Merkle, a scientist, in 1979 itself. But in 1992, these scientists or these researchers have found that this concept of Merkle trees can be incorporated into this blockchain technology, which will help it to become more secure, which will help it to put more number of transactions into a block. Okay. So in 1992, these Merkle trees were incorporated into this design. After incorporating this particular Merkle trees concept into this design, the blockchain has become more efficient. How it has become more efficient means, before that, what used to happen is, first a digital document will be timestamped. After timestamping a digital document, we will make it into a block. You can say like that. Okay. Next, the next block will contain one particular or two particular transactions. There was a limitation in incorporating many number of blocks into a single block. So after starting or after incorporating these Merkle trees concept into this blockchain, they are able to incorporate several documents. Like here, several documents were able to be incorporated into a single block. Previously, it was not possible because of several constraints. With this concept has helped them a lot. After that, this Merkle tree has become a fundamental part of blockchain technology. Okay. So now, whatever the blockchain technology which we are using, this Merkle tree thing, which they started initially, has become inseparable part. It's a fundamental part of this blockchain technology. Actually, this is a mathematical structure which is composed of hashes of different blocks of data, which serves as summary of all the transactions in a block. It also allows for efficient and secure verification of content in a large body of data. So let me explain it simply. For example, there was a block, there was a small transaction. Okay, there was a transaction here. Transaction is nothing but you can say like list of transactions, or like A paid B this many dollars, C paid D these many dollars, like that. All these will be entered into a page that we call which I am referring here as a transaction. So this transaction will have a code, something called as hash, which we are going to discuss later in our presentation. So this particular hash will be generated and it will be unique for a single transaction. So this transaction will be linked to another next transaction, which will have a particular hash, another hash, and will be linked to some other next transaction, which will be having a hash, like that. Previously, this was the scenario. Now, what has happened is, using this hash, by using this hash, and by using this hash, we are going to combine all these hashes and create a single hash here. Okay. This single hash will be called as a single hash of that particular block. The concept which I am telling now may sound bit alien or may sound bit new, but when we go further in this presentation, we will be able to understand this more clearly. Okay. So now, let me clear this off first. Okay. Right. Now, as I said, this Merkle tree is a structure first proposed by a scientist called as Ralph Merkle in 1979 itself. But it was a part of mathematical model or mathematical concept. As I told now, it combines hashes of two transactions or more transactions and finally generate hash of that particular block. Okay. Which, even though you are not able to understand here, we are going to understand this concept more clearly further in this presentation, because we are going to talk about how the block is formed, how the blockchain technology is formed, and all. Okay. Now, to build these Merkle tree transactions, to build this Merkle tree, as I told, these transactions are first paid together. Like I can say, there is a transaction here, there is a transaction here, there is a transaction, there is a transaction. And all these transactions to be put into a single block, a single hash need to be generated, for which these two transactions are paired up. These two transactions are paired up. Let us say there are some few more transactions. These two transactions are paired up, and a new hash is generated for this pair, and a new hash is generated for this pair, and a new hash is generated for this pair. And after generating hashes here, now we are left with three hashes. Again, we will pair up these hashes into pairs. Here one is left out, so this will be copied again. The same will be copied again, and this will be paired. Now we will get out of this, we'll get one hash here, one hash here, and finally these two hashes will be combined together to give out final hash of this block. So this is how Merkle tree works. The main purpose of introducing Merkle trees in this blockchain is to create a single hash for a particular single block, which is comprising of so many transactions inside. Next, for further improvement, in 2004, what has happened is a person called as Hal Finney. He is a computer scientist. Who is good at cryptography. He has introduced a system called as reusable proof of work. What is this reusable proof of work? This is the thing which I have referred to as consensus previously. Okay. So the consensus thing which I have referred previously is based on one such kind of technique called as reusable proof of work, which is a prototype for digital cash. The thing which we are calling as cryptocurrencies nowadays is completely based on this concept called as reusable proof of work, or we can even call it, we can generalize this thing and call it as consensus. Okay. So now it was significant and early step in the history of cryptocurrencies. As I have told, cryptocurrencies require a particular set of agreement to which all the people, in the sense, all the nodes should agree. So this has done the job. This reusable proof of work (RPOW) has done the job of bringing all the nodes which are participating in this blockchain onto a single platform and agree upon a set of rules. Next, that's why it is called as very much significant step in the history of cryptocurrencies. You can call it as cryptocurrencies beginning. Now, this RPOW worked by receiving a non-exchangeable or non-fungible hashcash based proof of work token in return. This created an RSA signed token that further could be transferred from person to person. Though this appears to be a bit complex, we can simply say that this RPOW enables cryptocurrencies to come into picture and to transfer these cryptocurrencies from one person to one person, or we can say like this has enabled cryptocurrencies to get transferred from one node to another node. This transfer of money or currency is very much important, and this is possible by using this concept called as reusable proof of work, which has been introduced by this person, Hal Finney. So what is the biggest problem which this RPOW has solved? This reusable proof of work has solved biggest problem called as double spending. What is double spending problem? I'll tell you that what is double spending problem. But for now, let us just go by this sentence which I have presented here in this presentation. By keeping the ownership of tokens registered on a trusted server, this double spending problem can be solved. Okay. Now, this server was designed to allow users throughout the world to verify its correctness and integrity in real time. Are you able to understand? Like the statement which I have told now is nothing but the thing which we are seeing in our day-to-day life, that is online banking. In online banking, what we are doing, we are keeping our money into a thing called as trusted server. Okay, means the bank server. The bank server will enable us to transfer our money, which is in our account digitally, to transfer our money, which is present in our bank account, into some other one's account with the help of this trusted server, and it will verify the transactions. This is called as centralized mechanism actually, but the double spending problem is got solved because of this establishment of trusted server in between. Okay, so till now we discussed how the blockchain technology, the idea of the blockchain technology has started. It started with time stamping of digital documents first. Later, what happened is after they are able to timestamp the digital documents, they tried to combine so many number of transactions into a single block. They are able to achieve this with the help of. So they are able to achieve this with the help of a concept called as Merkle trees. Okay. Now they are able to combine many number of transactions and put into a block. Now after that, because there will be so many nodes involved in the blockchain technology and it is a decentralized mechanism, there came a need for forming a set of rules, common rules for all these nodes which are present in this blockchain network. And the job and this requirement has been fulfilled by this person, Hal Finney, by introducing reusable proof of work concept, which has given rise to something called as cryptocurrencies. With the advent or with the introduction of this particular concept, double spending problem, which we are going to discuss further in our presentation, clearly that has been solved. Okay, now let us go further. Next, the famous person who we know as with the name Satoshi Nakamoto, he has conceptualized the theory of distributed blockchains. Okay, in 2008, he improved the design in a unique way to add blocks to the initial chain without requiring them to be signed by trusted parties. He previously it was like a centralized mechanism. As I told previously, the double spending problem has been solved by introducing banks in between, but it is a centralized mechanism. This person, Satoshi Nakamoto, has conceptualized a theory of distributed blockchains, using which there is no requirement of signing by these trusted parties. Means the role of banks in between has been removed out, and this blockchain has become a distributed network. Now, these modified trees would contain a secure history of data exchanges. They will store all the exchanges or all the transactions which has happened. It will contain the history of data exchanges. It utilizes peer-to-peer network for timestamping and verifying each exchange. What I mean to say is, in the first case where a bank is involved, when a person sends money to another person, first the money will go to bank. Bank will check whether the balance is there or not, and after it has checked and whether the person is facilitated to transfer money, after checking that, then the bank will transfer the particular money requested to the second person, let us say B. Whereas in this particular decentralized mechanism, this bank role, which is present in between of verifying the transaction, this role has been given to multiple people which are present in the network, because this blockchain network is a peer-to-peer network rather than a centralized network. For timestamping and verifying each exchange will be done by these peers. Okay, it could be maintained autonomously without requiring a central authority. Got it? So these improvements were so beneficial that makes blockchains as the backbone of cryptocurrencies. Cryptocurrencies without blockchain is as same as a digital currency. But with the introduction of cryptocurrencies into the blockchain, this has become a game changer. Today, the design serves as a public ledger for all transactions in the cryptocurrency space. If you want to store some data, if you want to store some transaction, that will be stored in a decentralized peer-to-peer network, which is a blockchain network, and cryptocurrencies will be running inside that network. Why? I'm going to explain later. Next, this evolution of blockchains has been steadily and promising. The word block and chain were separately used by this person Satoshi Nakamoto initially in the paper which he has published. But initially, with the advent of or with the popularity of this concept blockchain, they have combined them and calling them commonly as blockchain as a single word. And an interesting, an interesting thing or interesting fact about this person is till now, nobody knows who is this Satoshi Nakamoto. We have heard his name so many times. He has published papers regarding this blockchain and all. We call it, he has brought a revolution in this blockchain technology space, though we have or nobody has seen his photo or nobody knows him, who is actually he is. He is anonymous even till now. Okay, let us move further in our presentation. And here comes the introduction to the blockchain. What is blockchain? Introduction to the blockchain. So pay attention to this picture for some seconds. What actually is happening here? you're able to see there is some process happening there. There is some process happening there. What is that process? First of all, here there is something called as collection. What is this collection? What is it collecting? All these yellow colored dots or balls which are falling here into this block are transactions, different transactions. All these transactions will be packed into a block. After packing into a block, these blocks will be sent into the blockchain network, where this thing consensus will come into picture. Now all these transactions are verified here. After verifying, they'll be placed properly and sent for execution. At execution, these will be executed and sent for verification. After verifying, completely this block has formed, yet lacking one thing. What is that? Something called as hash. So again, the consensus will add hash here. Whatever you are seeing in this bottom is adding of hash. After adding of hash, it will be sent to this block to completely form into a blockchain. This thing will be already existing, to which a new block will be added, and this process goes on. We are going to discuss this process only all along our presentation. Okay, so let me go to the next slide. Blockchain. First, let us read out this paragraph which we have presented on your screen. Then let me explain what exactly that means. Blockchain technology, DLT, that is distributed ledger technology. It is distributed ledger technology because it is a peer-to-peer network, and it is not centralized network like a bank, digital banking or internet banking. It is a decentralized network that uses distributed ledger processing systems or technology for the efficient and secure transfer of business assets between member organizations in the network, with an architecture, framework, network technology, providing features of these features are very much important: tamper-proof, trusted, shared, replicated, permissioned, distributed ledger processing system. Okay. Actually, you can say that these are all the characters of a blockchain technology. Tamper-proof. Once you have entered a data, or once you have entered a transaction into a blockchain, once it got validated and entered into a blockchain, can never be tampered. We'll discuss the same thing with some examples, and we will see if you try to hamper a particular block or a particular transaction, what will happen, and how this mechanism is called as, can be called as tamper proof. And it is trusted because this is not centralized authority, and the authority which is sitting in the center should be trusted. If that authority which is sitting in the center of that network, if it is not a trusted party, then there will be a chance of fraud to happen. Rather, here we are using a decentralized mechanism. So, because of which this is a trusted kind of architecture. Next, it is a shared architecture and replicated, permission, and a distributed ledger processing system with consensus, provenance, immutability, and finality by recording and managing transactions. This complete the statements which have been given in this presentation on the whole means once you enter data into a block, it can never be changed. Okay, it can never be changed. Next, this block will be added. This block will be added in a network where there is no central authority like bank sitting in between. Whereas there will be, consider this is a block, there will be different nodes or various nodes to which this will be connected, and there will be a network, something like this. And these nodes which are sitting here in this peer-to-peer network will validate this transaction. Okay. Now, as I said, once you enter some data into this block, it can never be changed. There is no central authority involved in between. There'll be a peer-to-peer network, and these people will validate this. So all these network, all these peers will be agreeing upon, or they will be acting with the help of a set of rules. These set of rules are called as consensus, which I have told here. The word which we use here, consensus. Okay. Now, so these are the things which I have told now. Let me erase this link, what is present on the screen. Now, this data is recorded in the form of blocks. How? Using a technique called as hash technique. This forms the whole core of this blockchain. And this ensures encryption. That is how they are made as tamper-proof and secure. Because of which it leads to immutability and finality. Okay. So this can be called as introduction to the blockchain. What is its features, where it will be used, how it looks like. Now, let me show you in a diagrammatical way what is the decentralized mechanism. See, as I mentioned earlier, this blockchain technology is a decentralized mechanism. Okay, so in a centralized mechanism, there will be a centralized authority sitting in between of the network. All these people who are making transactions here, they will be customers, or you can say users or nodes. They will send request to this centralized authority to do some transaction, and then this centralized authority will timestamp and will verify that particular request. After verifying that particular request, he will transfer that money to this person, or you can say like that transaction is said to be verified. What is happening here? There is a central authority sitting in between. What if a fault comes at this particular node? If a fault comes at this particular node, this complete network goes down, right? So there is a dependency on a central authority. And as I said, trust this central authority, which we have made him sit in between of this network, should be trustworthy. Rather, let us go for this approach, which is decentralized. Okay. So in this decentralized approach, what will happen is there are multiple parties. There are multiple parties who are going to verify your transactions like this. There is no single central authority. So when a person sends, whether it may get verified by this person, it may get verified by this person, it may get verified by this person, it may get verified by this person. It may get verified by any of the people who are present in this particular network. Okay. There is no compulsion that only this person who is directly connected to this particular node should verify. There is no compulsion. The transaction which is initiated by this particular node can be verified by any node, any validator who is ready to validate this particular transaction. Okay. So this is the thing about decentralized. If you look at a distributed network, all the nodes will be interconnected with each other. And this is the structure of our blockchain technology, where there is a peer-to-peer connection, peer-to-peer network. Anyone can initiate a transaction, anyone can validate the transaction. Okay. Next, blockchain. The word blockchain means nothing but a chain of blocks. Blockchain is nothing but a chain of blocks, which will look like this. Okay. This is a block. This is a block. This is a block. All are connected and they are forming a chain. And we are not physically connecting these blocks using any physical chain or link. They are connected with the help of something called as hash. We are going to see deep into this concept later. So for now, just understand that blockchain is nothing but a chain of blocks. Here, a block means nothing but, you can say like this is a piece of code, and that particular piece of code contains a set of transactions. This is a transaction, this is a transaction, this is a transaction. So all this set of transactions will be hashed together with the help of a concept called as Merkle trees, or using the algorithm SHA, secure hashing algorithm. and they will be put into this particular block. Okay, all such blocks will be joined together with the help of something called as hashes, and this is how a chain of blocks will be formed. So what actually, see, whatever the data that is present inside the block can be anything. Till now, I have talked about transactions only. Means a set of transactions will be combined together and they will be put into a particular block. But there is no compulsion that we have to put only transactions into a block. You can even put records into this. You can put transactions into this block. Even you can write, for example, your the data, the amount of Wi-Fi data, the amount of mobile data which you are using, that also can be stored down into a block. Whatever you want that is present in digital form, that can be stored inside a block, and that particular set of things are called as a block in this particular blockchain technology. Okay, let me erase this thing once. Oh. Next, as I said, it can contain a transaction, or it can contain records. It can contain any data, any digital data inside a block. Next, this is one of the famous things which we have heard so many number of times. That is blockchain platforms, and the term which we heard so many times is Bitcoin. Okay, so for example, as I told, inside a block we can store any kind of data. The data can be transactions, the data can be records, the data can be anything. You can store even your photos into a block. There's no compulsion. It should be in digital form. That's it. So if you take example of Bitcoin platform, Bitcoin is not a cryptocurrency actually. It is a platform. In this, we will use blocks to store transactions only. What are these transactions? Let us say like X pays Y some $20, and Z pays B some $30, and G pays D some $15. All these will be listed together into a sheet, or you can say like into a piece of code. This is called as a transaction, and many such transactions will be clubbed together to form a single hash, and these will be placed inside a block. Okay. Next, this is the case in the example of blockchain, Bitcoin. Whereas there are other cryptocurrencies. You might have heard about this Ethereum. This symbol represents cryptocurrency or blockchain platform called as Ethereum. Actually, there is a fact here that we should know. Ethereum is a platform. It is not a cryptocurrency. Whereas Ether is the cryptocurrency which we use here. Okay. So Ethereum is a platform which is providing some services. It is a kind of blockchain platform. But the currency which runs on that platform is Ether. Whereas in case of blockchain is a platform. In case of Bitcoin, it is a platform, Bitcoin platform, and the cryptocurrency which is running in that platform is Bitcoin itself. If you are not clear about this, you can imagine that the Bitcoin platform is a country, okay, and Ethereum platform as another country. In this country of Bitcoin, the currency which is transferred among each other is Bitcoin, that we know already. Whereas in this country of Ethereum, only Ether will be running here. Ether is valid currency here, you can say. So with this example, I'm going further in this presentation. Bitcoin platform stores transactions into a block, whereas Ethereum platform also stores transactions into a block. Along with the transactions, we can even store something called as smart contracts. Smart contracts are, you can say like, it's a kind of path breaking thing in this blockchain platform, which are really helpful in our daily life in many applications. It finds many applications in our daily life. Okay. So there is a very good example about the smart contracts. Let me just introduce you the smart contracts in a single word. Smart contracts are nothing but these are like small, tiny computer programs, okay, which will reside in a computer code, and they will execute by themselves at a time which we have specified. Okay, like there is a set of tasks which you have to perform daily, and you wanted to automate it. Okay, so during that automation, first the task one. Okay, there is a task one which need to happen at 8 a.m. let us say, and there is another task two, which need to happen by itself or which need to execute by itself at 10 a.m. There is another task three, which need to execute itself at the time of 12 a.m., something like this. So once we have automated this particular complete set of tasks, when the time time becomes 8 a.m., immediately this particular program will be triggered by itself, and task one starts to get executed, and it will complete its execution. The start time will be 8 a.m. Similarly, exactly at 10 a.m., task two will be triggered, and that will start executing itself, and it will be completed by some amount of time depending upon the task. Next, similarly, task three also has completed, has started or has got triggered at 12 a.m. Now, in this example, the thing which we do daily in our daily life activities is this. Similarly, the smart contracts, let me erase this thing. Similarly, in case of smart contracts, what will happen is there will be a set of functions. Like, for example, let us say uh, you have to transfer some money to some person, but not now immediately. We will get a better example of these smart contracts later. But for now, let me give a small example, which says there is a person here. He wants to transfer some money to another person. Let us say he's A, he's B, but not today. He has to transfer some $20 of money to this B after 5 days. Okay. So rather than transferring after remembering this thing and transferring after 5 days, he has to initiate the process of transfer and doing it. If he writes the same thing into a smart contract or into a piece of code saying transfer $20 to B on after 5 days, there'll be it will be like today is 18th, so after 5 days it will be 23rd. On 23rd August, July 2022. If he says this in a piece of code, and if he writes this piece of code into a smart contract and puts it inside a block, automatically after 5 days, this will get executed by itself. It will check whether he has that particular $20 in his account. If he has, because he has written this particular piece of code in a blockchain or into a smart contract, this will get executed, and that particular money will be transferred to this second party B. Okay, this is how this thing happens. What do you say? The smart contracts work. There are bigger applications of the smart contract which we are going to discuss in the last segment called as applications of blockchain, where we are going to see where the smart contracts have been implemented in our daily life, and it has become a huge success as well. Next, similar to this Bitcoin and Ethereum, there are other coins called as altcoins. They may store some store, as I told, your Wi-Fi data. Some may store documents. Some may store files. If you create your own blockchain platform, you can store your data, like you can store your photos, you can store your files, whatever the digital data which you want to store, you can store it in a block. And that particular cryptocurrency which runs inside the blockchain platform which you have created will be called with its particular name. Got it? Next, as I told, this blockchain platform is a decentralized mechanism. Okay, it is not a centralized mechanism. So the same copy of blocks or the same copy of chain will be present with each and every person or with all the nodes of this particular blockchain network. This is a complete peer-to-peer blockchain network where the same copy of blockchain is stored or is present at each and every node. Okay, let me ask you a doubt here. What if what if this particular person who is having the same copy of blocks has got some issue with his hard drive, maybe like with his system, and this got corrupted. He lost this block, or the data which is present inside this block got altered by mistake. I'm not talking the case of hacking and all. I'm talking the case where accidentally the data which is present inside this block got corrupted. In that case, as I told, the same copy of blockchain which is present with this person is not present with this person. Is left out with only these two blocks. Maybe like he might have three blocks, but the third block got corrupted. In that case, what will happen? In that case, among this complete network, whatever the chain of blocks which is present with, majority of the people will be called as valid blockchain, and this will be updated by each and every person in this network. So after getting updated by each and every node, finally we'll be left with this particular same scenario where the same copy of blockchain exists with each and every node. To put this thing in simple words, we can say like, right. For example, there are different sets of blockchains present with every person in the node. Okay. So to find which is the valid blockchain for this particular network, what we will do is, first of all, we'll get the list of blockchains which is present with all the nodes and see the same copy of blockchain whether it is present with maximum number of people. Like for example, 51% number of people. This is 5. Okay. 51 number of people in this particular blockchain platform contain the same copy of a blockchain, and other 49% people have a different kinds of copies of a blockchain. Then the particular copy which these persons have, 51%, majority of the nodes which have, that will be called as a valid blockchain. This will be told to these 49% people also, and by declaring that this copy of blockchain is valid, they will update their particular blockchains so that ultimately all 100% of the nodes which is present in this particular blockchain platform will have the same copy of the blockchain. Okay, next. So there are different kinds of nodes in a blockchain platform. Not every person can validate. Not every person can initiate. Okay, so actually any person can initiate. Here, consider these are all nodes of a blockchain network. The node can be a big office. The node can be a simple mobile. The node can be a simple laptop. A node can be a simple system, desktop system. Okay, so these are all the members, or these are all the nodes of this particular blockchain platform. Now, whatever are shown in red color, those are called as validator nodes. And what are shown in green color, they are called as member nodes. Okay. So these member nodes can only initiate transactions, initiate or receive transactions. They can't validate. Whereas these red color dots, that is validator nodes can validate, initiate, receive the transactions. Like say this green dot, that is member node, want to send money to this particular green dot, this particular member node. These transactions can be verified by either this or this node or this node or this node. But these transactions cannot be verified by this. Why? Because this is just a member node and it is not a validator node. Okay. Similarly, in this example as well, the transactions can be initiated or received by these member nodes, that is green dots, whereas the red dots here are validator nodes. They can initiate a transaction, they can receive a transaction, they can validate a transaction. Okay. When I told this statement saying these validators will validate, whereas member nodes can only initiate and receive the transactions, we will get a doubt. Why? What is that? Why should they validate? Why should they validate? For example, in a centralized mechanism where a bank sits in between, the particular complete transaction cycle, when they validate a transaction, when they perform a transaction, they will get some commission out of it. So what this validator node will get them for validating a particular transaction? They will also get some rewards. Those rewards can be in terms of cryptocurrency. They may get bitcoins, or they may get transaction fee. So who will decide whether they will get cryptocurrency as reward or transaction fee as reward? That will be decided by the platform which they are in. If they are in Bitcoin platform, they will receive bitcoins or cryptocurrencies as their reward for validating. If they are in some other platform, say Ethereum, I think Ethereum, yes. If they are on Ethereum or Tejos, they will receive transaction fees rather than cryptocurrency as reward. Okay. Next. What is the need for blockchain? Now, this blockchain can be integrated into multiple areas. Okay. It finds its application in multiple areas. The primary use of blockchains is as a distributed ledger. Okay. Only validator. Okay. I got a question here. Let me answer this and move forward. And only validator can receive the reward. Yes. Let me go back to that particular slide where I explained about this. Yes. Only validators can get a reward. Like, let me draw a small this thing here. He's a validator. He's a validator here. Red color dot. We'll go with the same convention which I have been using here along this presentation. He's a member node. So when I'm, let me write validator, he's a member node. Okay. Validator node only can verify a transaction. I'm not talking about this particular validator node only can verify transaction. Here, if there is some other validator node, he also can verify transaction. He also can verify transaction. But among these validators, only one person will be successful in validating that particular transaction or validating that particular block. For example, let us say this validator has become successful in validating that particular block. So because he is successful in validating that particular block, he receives the reward, but these people will be left with no reward. How much ever the work, how much ever the amount of work which they put into this validation, that won't matter, because ultimately only one person was successful enough to validate that, so only he will receive the reward. Okay. So let me go further into this topic. Need for the blockchain. What is the need for this blockchain? There are so many applications of this blockchain which we might have heard of, like in banking they will use, in finance they may use, in government, healthcare, insurance, media, entertainment, retail, etc. In so many fields, this blockchain finds application. So let me give a simple example here where we can use this blockchain. Okay. See, I am setting up a government office. Okay, which will verify the land records. Okay, land record means which will verify the land records. So a piece of land which is having some particular ID. There is a piece of land. There is a piece of land. Let us say this is owned by some person A. When this person sells this piece of land to another person B, this registration need to happen. This registration need to be carried out, and it need to be validated. This particular government office, which holds all the land records, which will do the job. Now, if they are employing a blockchain technology for doing this transaction of transferring this particular piece of land, let us say land has some number 256. I'm talking about survey number, okay, land number, we can say. The land having survey number 256 has been owned by A previously, and he has sold this piece of land to B. And this particular transaction will be saved inside a block, which is stored here. And this block will be sent all across the network of these government offices. I'm talking about a public blockchain network where only these government offices which keep land records are present, and it will be transmitted all across this network where validators first will validate that particular transaction, and that particular block is validated, and ultimately this will be added to the already existing chain of blocks. Okay, got it? Let me summarize it in simple words. Let us say already there is a chain of blocks which is present in that particular government office server. Server in the sense I'm talking about a decentralized mechanism where there are different nodes, and every node contains the same set of blocks. Okay. Now, because of the land transaction, the transfer of land from a person A to the person B, a new transaction has been initiated, and this new transaction has been stored into a block along with some other transactions as well. And that particular new block will be added here by getting validated by other nodes which are present in this particular network. Okay. This is one of the application of this blockchain. If you see this medical, healthcare thing. Okay. For example, a patient has come to come to hospital for health checkup. So all the tests will be performed on that particular patient, and all those reports will be saved into a transaction or into a block, which will never change and which will never get deleted, because even if it gets deleted in particular one system, the same copy will be present in other systems or other nodes which are present in that particular blockchain. Okay. Now that particular records or patient reports will be saved into a block chain. You can say there is a blockchain already present, which is having the transactions or reports of other patients as well. Now, this will be saved in the blockchain network of that particular hospital. If this person goes to some other hospital, let us say X, he goes to some other hospital X, then what will happen is all these records which are saved here in the blockchain of some other hospital Y will be requested by X. The hospital X says the patient who has been consulting your hospital has come to our hospital for consultation. Now, we need his record of the reports which he got tested in your hospital. Please transfer us. Then the patient who has come to this hospital will validate that. I'm not here saying the validation is blockchain validation. Will confirm that yes, really this hospital X is asking for the records, and I have come to this hospital X for consulting. After getting these requests from hospital as well as patient, this hospital transfers that particular that piece of data which is present in their block into the blockchain which is being maintained by this particular hospital X. They'll not transfer, remember here, they'll not transfer complete block, because that complete block will contain the records or the reports of so many patients, not just his. So they will transfer only that particular set of piece of data into the blockchain network of this hospital X. Why we should why we should employ blockchain here? Why can't we go with just normal data storage, which the hospitals have been using now? Because the data which is stored by that particular hospital may get deleted, may get corrupted, may be tampered by some other person. So to avoid the scope of getting these many kind of things, we will store the reports of the patient into a blockchain, which will be immutable. Once you store into a blockchain, it cannot be changed or it can't be tampered, as I said earlier. So need for blockchain. First, time reduction. Blockchain will reduce so much of time. How? Whether here I'm talking about the validation of a blockchain? No. I'm talking about time reduction here. When I'm talking about time reduction here, I'm referring to this thing. Like, let me take the same example, the piece of land number 256, let us say. This land is transferred from A to B now. So who is the owner of this piece of land? B. Yes. I hope you are all following this lecture. Okay. You can even respond in the chat as well if you want to answer any question here. Next. So now the owner of this land is B. Previously, before B, who was the owner of this land? A. Before A, there might be some other person, some Y, who was the previous owner of this particular piece of land, and there might be some other person who was the actual owner of this piece of land. So to find who is the actual owner who has this piece of land initially, we can make use of this particular blockchain where every record will be stored. So we can easily go through those documents and find out who is the actual owner of that particular piece of land initially within no time. Within no time, it will not take much time rather than compared to the physical verification of the finding out who is the actual owner of that piece of not actual owner. We can say who is the initial owner of that particular piece of land by using physical records will take a lot of time. Whereas here, when we employ this blockchain technology, it will reduce the time so much. Next, unchangeable transactions. Once you enter a particular piece of data into a block, it can never be changed. So these transactions will be called unchangeable. This will improve the trust because once a transaction is entered, it can't be changed and it can be trusted. This particular piece of data can be trusted. Next, reliability. So because the transactions are unchangeable and the same set of copy will be saved in so many other nodes, even if the blockchain data present at one particular node has got transferred, the same copy will be present with all other nodes in the network. We can say that it is reliable. The data will not be lost and data will be authentic, and the data stored inside a blockchain will be tamper proof. So it is original, we can say. So this is how we can say like the blockchain is reliable. So we wanted reliability. So we wanted a technology. We wanted to save the transactions as unchangeable format. We wanted a technology. We want to reduce the time of finding out or dating back the originality or the origin of the particular transaction. So we wanted to reduce the time. Next, we wanted a decentralized mechanism rather than using a centralized mechanism as in the case of internet banking. We wanted to employ a decentralized mechanism where there is no need of employing a trustworthy party in between. Okay. Next, we wanted collaboration of different nodes. As I said, in decentralized mechanism, there will be a collaboration of different validator nodes. So we wanted a network which contains collaboration of so many people. And most important of all, we wanted security. How the security is ensured in this? With the help of things which we are going to discuss next. Within no time, we are going to discuss how it is secure. Okay. So we are in need of all these things. We wanted to go back to the initial origins of a particular transaction easily in less time. And we wanted to store transactions which cannot be changed later. We wanted reliable network or reliable data storage. We wanted a decentralized network. We wanted collaboration of different nodes, and we wanted a secure network. And for all these requirements, for all these questions, we found a single thing called as blockchain. Blockchain ensures all of these things. And all these points will be discussed later, how it can reduce time, how it can make the transactions unchangeable, how it is decentralized, how it can ensure security and all. Now, why the need for this new technology emerged? Here, the thing which I talked initially, something called as double spending. The problem of double spending has been solved by Anne Finlay. So, first of all, let me discuss what is this double spending problem. Let us say there's a person Ram. Okay, he is selling. See, for example, he is tendering a 2,500 rupees. Okay, 2,500 rupees bill to Rajeshwari in exchange for a book. Okay, she has sold this particular piece of books to him. In exchange of that, he has paid 2,500 rupees in physical currency. Okay, so now he has paid out. For example, he has some 10,000 rupees. He has some 10,000 rupees. He has paid 2,500 rupees to her. He will be left with only 7,500 rupees. So now, once she receives this physical bill of 2,500, there is no way of Ram Iyengar to reuse this money for some other transaction. Okay, he will be left with 7,500 only. Again, he will not have 10,000 rupees after paying 2,500, because once it is paid, right? Next. Now, this particular physical currency is under the possession of Rajeshwari. So, this is the case with physical currency. There is no issue in that until this person Ram, what do you say, counterfeits that notes, or he produces duplicate notes. We assume that this particular case is not possible, or we say that the particular counterfeit notes are not original enough to look as the original notes. So we say that in physical currency transactions, this is the thing which happens. Now, let us see an example of digital transaction. Now, she sends some book to this person, Ram, but Ram Ram pays her 2,500 rupees in the form of digital coin. Let us say he has 10,000 digital coins. He sends 2,500 coins to her. Okay. Now, after sending 2,500 digital coins, what he does is he will be left with 7,500 legally, if you want to talk. What it says is he will say that he will make this 7,500 into 10,000. He will change that value. He will edit that value in his account. And finally, he has 10,000 again. He will send again 2,500 to other person, Snehalata, let us say. Means he is paying the same amount of 2,500 here as well as here. This is called as double spending problem. This is the problem in digital form. You may think like how he will get 10,000 rupees in his account. How is that possible? Whether how bank allows that to happen. I'm talking about a scenario where there is no bank employed. There is no bank in between. I'm not even talking about a blockchain platform. I'm talking about a general scenario where, hypothetical scenario where a person, for example, let us say person Ram says, or he has 10,000 rupees in his account. What account? Not a bank account, just a wallet, let us say, digital coin. He sends 2,500 rupees to a person, Rajeshwari, in exchange of a book. And he will be left with 7,500 actually. But he edits that 7,500 as 10,000 again. Again, he sends 2,500 to some other person, Snehalata, in exchange of some other product. So, in this process, in this example which I have told, the same 2,500 rupees has been transferred to Rajeshwari as well as Snehalata. This is called as double spending, which should be avoided in digital currency. And to solve this problem of double spending, we have come up with a centralized authority, that is bank. Now, in the same previous example, here, what if I employ a bank here? What if I employ a bank here? Let us say this is a bank, okay? This is not a jail. This is a bank, let me see. I have employed a bank here. Once he sends 2,500 rupees to Rajeshwari, or the first person, what bank uses, it will first check how much is the amount of money present in the account of Ram. It gets to know he has 10,000 rupees. After getting to know that he has 10,000 rupees, what it will do is send 2,500 rupees to her and immediately remove 2,500 rupees or delete 2,500 rupees from his account. So finally, he will be left with 7,500 only. He can't again spend the same 2,500 to send to this other person's Nehla. Why? Here, the centralized authority bank ensures that his particular account balance will be updated time to time based on the transactions which he does. Got it? So the problem of double spending can be eliminated by introducing a centralized authority called as bank, like employ a centralized authority to monitor all the transactions. Now, this centralized authority, how it will eliminate this problem of double spending? Because it maintains a ledger book recording all the transactions. First, the transaction which he did he has sent 2,500 rupees to a person. That will be saved. That will be recorded in a ledger book first. Next, whenever he transferred 2,500 rupees again to second person, Snehalata, that also will be first checked with the ledger book by recording all the transactions. Now, this Ram Iyengar, he has to send his digital money to the bank, would make entry to his ledger, debiting Ram's account. Now, the amount of transfer which has happened will be debited from this person. Okay. Now, after ensuring that Ram Iyengar has sufficient balance to pay, for example, let us say he has account of 1,000. Let us say next, if he wants to transfer 2,500 rupees to her, whether that is possible in the scenario where there is a bank in between, and he wants to transfer 2,500, where he has only 1,000 rupees in his account. Now bank verifies this. First, it checks whether the amount of money which he wants to transfer that is present in his account or not. In this case, there is no that much amount present in his account. So straight away the bank denies this transaction and sends a message or a notice to this person saying you don't have sufficient balance. Got it? So after ensuring that Ram Iyengar has sufficient balance to pay for the digital money which he wants to set, would send the money to the Rajeshwari, creating her account in the ledger. Okay. So first it will check whether the particular amount of money is present in this particular what is the sender's account. Once it is ensured, then only the transaction will move forward. Next. Now, by doing this process, we ensure that this particular double spending problem will be solved. Okay. Next, this also provides another benefit in validating the authenticity of each coin, that is digital money. Every rupee, every coin, every piece of money which he pays, Ram pays, will be validated or will be authenticated first by the central bank. Then that will be sent. So this also provides another benefit in validating the authenticity of each coin, that is digital money, that it receives in the transaction. So the fake money that was previously used by this person Ram to send is eliminated. Like duplicate money, as in the case of Ram paying to Snehalata using a copy, would be easily rejected and prevented from circulation, because a complete record of the transactions will be saved. Next, the introduction of centralized authority, though it solves the double spending problem. Like I have told what is the problem of double spending. Okay. Now, after explaining the problem of double spending, I have told the solution to this problem of double spending. How? By introducing or by employing a central authority which will verify all the transactions, we are able to successfully eliminate this double spending problem. But this is not a final solution. What is the issues or what is the problems which has arisen because of introduction of a central authority, or this introduction of centralized authority, though it solves a double spending problem, though it introduces another major issue, that is the cost of creating and maintaining the centralized authority itself. To make a transaction of some money online through a bank in online banking, what happens is, for the amount of money which he transfers, bank will take some transaction fee. Bank will take some commission. Why they will take commission, or why they will take transaction fee? Because they have to create that mechanism system of maintaining all those ledgers, and they have to maintain the centralized authority itself. Okay. So for all the maintenance of all those things, they will take commission or transaction fee from this thing. So first is, we talked about what is the problem, double spending, and we talked about the solution for that by creating a bank or centralized authority in between. And we talked about the problem arising from introducing centralized authority. Though it solves this double spending, it introduces extra costs for maintaining those things again. To solve this problem, so I'm going to read about the same thing again. As the banks need money for their operations, They start cutting commissions on each currency transactions they do for their clients. This sometimes can become very expensive. We may think like they will take very less amount of transaction fee, but if you look at the case of overseas transfer, like if I want to transfer some money from one country to another country, what will happen is multiple banks may be involved in this particular entire deal of transfer. So when there are many number of banks or many number of agents involved in this thing, they will all take some commission for their operation for this transaction. So ultimately, you will be left with so much of heavy transaction fee. Okay, so to solve all these issues, we have introduced something called as digital currency, called as cryptocurrency, or let us call it by the famous name which we know, that is Bitcoin. Got it? So this particular issue of heavy transaction fee can be eliminated by introduction of digital currency called as cryptocurrency. Got it? Or we can call it as Bitcoin. Actually, cryptocurrency cannot be called as a Bitcoin. Bitcoin is one of the cryptocurrencies. Okay, right. Next, working of blockchain. How the blockchain works. This is the same image which I have told previously, which I have shown previously. The chain of blocks. True to its name, blockchain technology or blockchain is a chain of blocks that contain information. What is the information contained that this block contains? Can be anything. It can be transactions, it can be Wi-Fi data, it can be your photos, it can be your files, it can be your documents, whatever. Whatever that is present in a digital form. If you want to store in a block, you can store. So these blocks will be stored in the form of chain. As I told, each block contains data that can be anything, transactions, records, anything. Now, what will the block contains besides the data which is present in it? When I am referring to the data present inside the blockchain, I am referring to the set of transactions. I am referring to the digital data or digital code which we have put into this block. What it will contain? First of all, as we know, this data will be present inside a block. Next, along with this data, there will be some other things which will be present inside a block. That is hash. Hash is nothing but, you can think like hash is a kind of fingerprint for this particular block. Okay, next, hash of previous block. This is very much important. Along with the hash of this particular block, it will even contain the hash of previous block itself. Okay, like here, this will contain the hash of this block. Along with the hash of this block, let us say it will have hash 1. It will have hash 2. Okay. Along with the hash of this particular block, it will also contain previous hash. Okay. What is the previous hash? It is the hash of this previous block, which is hash 1. Why should we store this hash 1 here? Because to form a chain of blocks, we should know that this particular block which is having hash 1 is the means is the hash. Sorry, let me say it clearly, simply. Like this block contains its own hash, and this block contains the hash of the previous block. By storing the hash of previous block also, it ensures that this chain link is maintained. How we will know that this block comes after this block? By seeing this previous hash. Okay, previous hash is hash 1. Now, the block which is containing hash 1 is its previous block. So this is how we'll get to know that this is how we're able to maintain the particular chain of blocks. Now, what if I change the data which is present in this block? Even if I change a minute change in this data, this hash will be changed. We will see this practically as well. I'm going to show this as well. Now, even if you make a minute change in this data, hash is going to change. Next, what the data is contained. Data means the data which is present inside the block. Okay. Next, hash. Hash, as I told, it is a unique number that is assigned to each block. It is very much unique. You can think like it is analogous to the fingerprint which is present inside this block. Okay. Next, hash of previous block. hash of previous block in order to maintain the chain link, right? So in order to maintain the chain link, we store the hash of previous block as well. Got it? Next. As I told, the hash of a block is similar to fingerprint, that is random and unique, and is generated based on the data present in the block as well. Like, let us say there is a block here, and this block contains some transaction, let us say ABC. This has some hash, like 1, 2, 3, 4, some E, F, G, like that. This is the hash I'm talking about. And this is the data which is present inside this block. If I add a single letter here as a D, this hash will entirely change. And this hash will become something like 4, 5, 8, A, Z, something like this. So even if you make minute changes, it will change. And this hash will be unique for a set of data that is present inside a block. Okay. Now, how a blockchain is formed. Let us look at this scenario a bit deeper. Now, actually hash will be hash will contain many number of letters. Just for example, let us consider this is the hash of this particular block. Along with data, it contains hash as well as previous hash. But is there any block behind this? Before this block, is there any other block? No, right? So, because that is the first block present in this chain, that is the initial block, we call this as genesis block. For this genesis block, the field of previous hash will be all zeros. Why? Because this is the genesis block. This is the first block present inside this chain. Now, next, when you consider the second block, it will contain a particular hash, which is unique. And along with that unique hash, the previous hash also will be stored. See, the 1Z8F, that is the hash of previous block, is stored here as previous hash. Next, if you come to the third block, it will have a unique hash, and it will store the hash of the previous block 6BQ1 here as well. In order to maintain this chain, this particular kind of approach is followed. Okay. Now, previous hash for the starting block or genesis block will be all zeros. As I told now, the previous hash for the starting block or genesis block will be all zeros. Right? Next. And this, by using this approach, we are able to maintain this particular chain of blocks. Is blockchain secure? When I was talking about the need for blockchain, I told so many things like less time required for that. We were in a need of reliable kind of technology. We were looking for a secure kind of technology and all. So my question here is whether this is secure. How much secure is this blockchain? Let me tell this by taking some example here. I'm considering the same block here. I'm considering the same blockchain which we have seen here. Now, what will happen is, let us assume that a hacker tries to change the data of a block, and even he succeeds in doing so. Let us say he hacked a system. He wanted to change the data present inside this block, and he is able to successfully change the data which is present inside that block. Let us say, after changing, what happens? He needs to modify and validate the succeeding blocks in the chain as well to be completely successful. Right? As I said, he is able to change the data inside this. After changing the data, hash will change. So he needs to generate a new hash. Right? Next, once he is able to generate a new hash, what will happen? Here, in the next block, the value which is present as previous hash will be the same, that is 6BQ1 only. But because he has changed the data, this will become something like X243, something like this. So this need to be updated here again, X243. After updating previous hash, the hash which is generated here will be generated with the help of data present in it as well as previous hash. Though he has not changed any data here, The next block, one minute, I got a question here. The next block have different previous hash. The next block have different previous hash. Okay. The next block has, yes, got it. Okay. Yeah, I thought you were asking some doubt. Yes. So here it will have 6-bit Q1 only, but it has been changed to X243 by this hacker. So again, here he has to update X243 here. Let us think that he has updated X243 here as previous hash. Though he is successful in doing so, what will happen is, though he has not changed any data present in this block, he has changed the previous hash here. So ultimately, the hash present for this block will change, has to change, because this hash will be generated with the help of data as well as previous hash. So because of this, he has to change this hash also. Let us say he has to change this hash as 72AB, something like this. Yes. So I'm going to talk about that only. So what happens is, he has changed this, what is it? He has changed this hash also. But what will happen? Again, the same scenario will happen for next subsequent blocks. So ultimately, what will happen is, if he wants to change the data inside a block, he has to validate each and every subsequent block in this particular chain. Let us say there is a chain of block like this, where he tries to change the data present in this block. Once he changes this data present in this block and validates, ultimately he has to change the data, or he has to validate all the subsequent blocks. So this is a very difficult thing. It will take so much of time, so much of processing. Let us say he is able to successfully do that also, because he is very much talented. Let us say he is able to do that as well. But let us look at the bigger picture. The same copy of chain of blocks will be present with each and every node in this network. Let us say there are 10 such nodes. Okay, there will be so many number of nodes. Just for simplicity, let us consider there are 10 such nodes. Okay, when there are 10 such nodes, he is able to successfully change the block chain in this particular node. But when there comes a question of finding out which blockchain is valid, as I said, more than 51% of the nodes present in the network should contain the same copy. Whereas here in this example, this contains same copy. Whereas this particular node contains a different copy of blockchain. So ultimately, when they check which blockchain will be called as valid blockchain, the copy which is present with these nodes will be called as valid blockchain. Got it? The copy of blockchain which is present with this node is called as invalid, and ultimately again the same copy of blockchain will be stored in this. So whatever the effort which he has put in modifying all these blocks and validating in all these blocks will be gone into the gutter. Ultimately, the same blockchain will be validated here. The modified blockchain will be called as invalid, and that will be just discarded. Okay. Now, with the help of this thing, what we can say, if a hacker wants to hack, if a hacker wants to change the data in a block of a chain where there are 10 number of nodes, he has to hack successfully 6 nodes. After hacking 6 nodes successfully, he has to change the chain of the blocks which is present, or the copies of the blocks which are present in these 6 nodes, into the same copy as per the requirement which he wants to. Okay. So let us summarize this thing, whatever we have discussed here. First of all, if he wants to change the data in just a single block, he has to validate all the subsequent blocks. Next, after successfully validating all these blocks, he has to take control of more than 51% of the nodes of the systems which are present in this particular network. So after taking control of more than 51% of the systems which is of the nodes which are present in this network, he has to do the same process of validating all the other blocks and changing the data in particular block everywhere. So what will happen? Ultimately, he will end up with nothing. It's very difficult to do. it takes so much of processing power, it takes so much of time. So we can say like this is nearly impossible. So now let me ask you the question again. Is blockchain secure? Is blockchain secure? You can respond in chat so that I can get to know like you are able to follow this presentation and you are able to understand. Yes or no? Yes, people are responding. So with this, I'm understanding that you're able to follow this lecture. Yes. So we can say like blockchain is very much secure. Yes. So shall I move forward in the presentation? Let me move forward in the presentation. Next. So this is a block.
I think, Mr. Naveen, I think we take a 10 to 15 minutes break. And
Okay.
after that, you may start the practical demonstration.
Sure, sir. Sure, sure.
Yeah.
So,
I request to all participants, if you have any doubt or query regarding the topics covered by Mr. Naveen sir till now, you may please unmute yourself and ask. So we will, after that, we will take a 15-minute break. And after break, Mr. Naveen sir demonstrate practically how hash has been created, how block has been created. So I request you to please unmute yourself one by one and ask if you have any query till presentation is covered.
Hello, sir. This is Anil.
yes,
Sir, I have a question.
yes, yes, sure.
How do these blocks communicate with each other? Like, example, when we do in the web, like if I open google.com, so there is a DNS server which knows the IP where to connect to. So how do these blocks know that where is the next node and where is the previous node and what is the IP of everything in this network?
Okay. So for now, let me clarify one thing that node is different, block is different. Like there is a node here, which will have a set of blocks, something like this. Okay. Now, if you are adding a new block here, okay, when you are adding a new block, there is no such thing called as next node. There is no such thing called as next node. This block will be transmitted all across this network for all the nodes. There is no such thing called as, you can think like it will broadcast across the network. Okay. So
No,
once
so
this
it is broadcasting to whom?
to every node present in that network.
So
You
does
can
it
think
have
of
the IP address of every node?
yes, yes, because they are forming a network. It will contain the IP address of every other node.
Let me clarify, Naveen sir, kindly allow me to explain.
Yes, yes.
Actually, sir, you
Yes.
are talking about the IP protocol and TCP UDP protocol. That thing is not implemented on the blockchain. In the blockchain, in the entire information is stored in a database, and it is replicated and it is available to all nodes. So once if anybody create a new transaction, or you can say a new block, that block information sent to all nodes. And if all nodes verify that whatever the new hash has come, once they verify, then it may added on the node, and that information available to all the miners, or you can say all the validator nodes. This is not the concept of TCP/IP that a connection is there. There is you can say that the entire information is stored in a some sort of database kind of thing, and the entire information of the previous block and the upcoming block, all information shared to all validators as well as miners, right? So there is a possibility that the internet connection has been break. So that is not, you can say, because if you heard that the IP protocol is a connectionless and TCP is connection oriented. So here connection is not established. Node is not a, you can say, a PC. It is a kind of information that available in the encrypted form and which is available to all. Only thing is that the public key is with all node peoples, and they have the ability to view the contents. Means they able to view the previous hash and the hash value and nonce value. They not able to see the content. And on the basis, the person who update, or you can say that the person able to edit the information, those person who has a private key. So block has been created with the help of private key and validate with the help of or view by the public key. Right? So I think I try my level best to answer your query. If you have still doubt, you may please ask. So Naveen sir now proceed to more elaborate about the blockchain.
So I hope that this has cleared your doubt, what Neeraj sir has explained.
Yeah, somewhat.
Okay.
Still, sir,
So,
if any doubt, you may please raise. Otherwise, a lot of confusion as arises in the upcoming sessions, because this is the building of the blockchain. Naveen sir present to you. If any doubt is still in your mind, then you not able to cover the upcoming topics related to the blockchain. You may raise if you have any doubt, any query. Unmute yourself and ask your query.
Anyone have any doubt? Okay, let's break for 10 minutes, and after 10 minutes, all are join. Any question, query, so please write in the chat box. Okay. So we are all see back again after 10 to 15 minutes. Okay, I inform you. Thank you.
Everybody take some refreshment or take some snap, and we will join shortly after 10 minutes.
During you have any doubt, you can already in advance put in the chat box after joining after 10 minutes. So again, we discuss and then start the further session. Thank you.